questions from you guys. Again, so at this point we've assigned worksheets 1 and 2, or if you have something else that you want to ask about still, I'm happy to entertain that. Does anyone have any questions from homeworks or others? Kiara? Worksheet 2, number 7. Sure. This is a good one because it's got the negative answers, or answer, I should say. Okay. So first thing I want to do is kind of draw my picture to figure out where my answer should lie. So build out my XY axis. Now if I look at this piece, that's telling me my answer is negative, right? My answer needs to lie between 2 negative values. So I know when I start counting, I know I'm going to be going clockwise and counting with negative values. So 0. And then negative pi over 2, negative pi, and then negative 3 pi over 2. So I can see there that my answer lies between negative pi over 2 and negative 3 pi over 2. So something here in quadrants 2 or 3. Then I go and I look at this piece. This is saying that sine theta is equal to negative 0.56, or specifically just that it's negative. So if I do my all silly turtles crawl, I know that sine then is negative in quadrants 3 and 4. So I can see my answer should lie here in quadrant 3. So that's my angle. So far, so good? Kiara? So far, so good? Okay. I'll draw in my alpha. So here is my alpha, always drawn between the terminal side and the x-axis. So now all I need to do is write down what alpha is. So alpha is going to be the inverse function, but I also need to remember that it's an absolute value. And then my last step is going to be writing my equation for theta. So the first part of this equation is the piece of the x-axis that makes up my alpha. So that's the pi, or I'm sorry, negative pi. And then to decide whether I should be adding or subtracting alpha, it's going to be based on which axis I cross before I hit that terminal side. Since this is a y-axis and a negative answer, that tells me it's addition. If it was a y-axis with a positive answer, it's the opposite, it's subtraction. So this should be negative pi plus alpha. At this point, I'll fire up my calculator. So negative pi plus sine inverse. And I'm going to do the absolute value in my head. So I have negative 2.55-ish. To check my answer now, I'm going to start by checking to see if sine of my answer gives me negative 0.56. Sure does. Step 1 of my check is complete. The next thing I want to check is to make sure negative 2.55 is in between negative 3 pi over 2 and negative pi over 2. So I see negative 2.55 is bigger than negative 4.7. And I see that it is less than negative 1.57. So I am convinced that my answer of negative 2.55 is correct. Is that okay, Kira? So if you can get the picture drawn, that's the hardest part. Once you have that, the picture tells us how to write everything else. So the picture is the key there. If you can draw that effectively and get everything in the right spot, should be pretty smooth sailing if you remember how to format your equation. Again, it's always like theta is always going to equal the x-axis part of alpha, and then plus or minus, and then alpha. Yeesh. There we go. And the way we'll choose whether we're adding or subtracting is our answer supposed to be positive or negative? And then what was the axis that we most recently crossed on our way to the terminal side of theta? So that's, once we have our picture, we'll use it to write our equation. Every equation we write is going to kind of be in that form. So that's kind of the rule for how to write your equation. The picture is the hard part. If you get the picture right, all you have to do is kind of follow the format and, you know, bingo, bango, bongo, there's your answer. Do I have other questions from homeworks? Okie dokie, suit yourselves. Let's move on and finish up section 4.1. Reminder, what should we be expecting this week? What should it cover? Worksheet 1 and 2, right? Okay. So a couple of loose threads here that we're going to cover here, and that'll finish us up for section 4.1. So the first thing is, if you see the prefix arc tacked in front of like a sine, cosine, tangent, etc., just means the same thing as inverse. So like arc sine of 0.5 is the same thing as sine inverse of 0.5. They mean the same thing. Don't be confused. Just a different notation. Depending on the textbook, you may see all of one or the other, a mix of both. You'll probably see a mix of both in the assignments that I ask you to do. Don't be confused, they mean the same thing. Everybody cool with that idea? No big deal. What I want to talk about next is I want to do some practice looking at the composition of a trig function and an inverse trig function. So for example, let's say we have cosine of sine inverse of 0.5. Everybody's okay with that? So when I see like one function tucked inside of another function like this, I'm going to be working from the inside out. So I'm going to take the innermost function, and I know that sine inverse is giving me an angle theta. Now, unlike your homeworks on worksheets 1 and 2, I'm not given a range over which to solve for that angle theta. You guys notice that? Like in the worksheets 1 and 2, I had like some thetas between like pi over 2 and 3 pi over 2 or something there. What do I do if I'm not given a range of values? Well, then I have to use the fundamental range for my inverse trig functions. So that's these guys right here. So this time we're going to be working at from negative pi over 2 to positive pi over 2. Is everybody okay? So if you're not given the values of what your answer should be between, you have to use these ones. So I'll write that down. Okay. So I have 0, and then if I go to the right, because I could have, or if I go clockwise, I could have a negative answer, right? Or I could go counterclockwise, because I could still have a positive answer. So I know my solution here is going to lie between in quadrants 1 and 2, right? Or sorry, 1 and 4. Everybody's okay there? If I look at this guy, I know that sine theta has to be positive. Well, that happens in quadrants 1 and 2. So my answer needs to be in quadrant 1. Is everybody okay with that idea? Okay. So I'm going to go to my unit circle, because I recognize 0.5 as a unit circle value, right? So I'm going to go to my unit circle and look for where the y-coordinate is 1/2 in quadrant 1. Why am I using the y-coordinate? Because it's sine. Very good. And we just established why it's in quadrant 1, right? So if I look at my unit circle, what is the value, or what angle has y-coordinate of 1/2 in quadrant 1? I think you have a unit circle on the back of your test if it's still sitting out handy on your table.
Is it root 3 over 2?
That's the x-coordinate. The y-coordinate is 1/2. We're looking for the angle, though.
Oh, 60.
But we want it in quadrant 1. But we want it in radians.
30?
Pi over 6
Oh.
is what we're looking for. So what we are doing now is going to do cosine of pi over 6. Is everybody okay with that? How do I do cosine of pi over 6? I go to my unit circle. I locate the angle pi over 6. And I look at the x-coordinate, which is square root 3 over 2. And that's my final answer. So it's just like a two-step unit circle problem, right? Use the inner part to find the angle, and then I'd use the outer part to evaluate cosine of that angle. So far, so good? Okay. Let's do another here. Look, notice I flip-flop these ones here. So I put the inverse on the outside and the regular trig function on the inside. Doesn't really change much. Still start with the inside. So the first thing I'm going to do is try to locate negative 3 pi over 4 on my unit circle. So find the angle, negative 3 pi over 4 on your unit circle. What do you notice? It's not there, right? Because all our unit circle angles are positive. Oh no, what do I do? Not going to be looking at a reciprocal. I'm going to find an angle that's coterminal to 3 pi over 4. How do I find an angle that's coterminal? Subtract or add 360, but if it's in radians, I don't want to add degrees to that. I want to use, instead of 360, 2 pi. So to add 3 pi over 4 and 2 pi, what do I need to have? Common denominator. What would that common denominator be? 4. So I'd have negative 3 pi over 4 plus 8 pi over 4. And now that we have common denominators, how do I add fractions with common denominators? We add the numerators, so negative 3 pi plus 8 pi is 5 pi. And what does the denominator? Just stays the same, right? So if I go to my unit circle, I can do tangent of 5 pi over 4. Remember, on the unit circle, tangent is y over x. So at 5 pi over 4, what is the y coordinate? So at 5 pi over 4 on your unit circle, what is the y coordinate?
2 root 2 over 2.
Yes. And the x coordinate is?
Same thing.
Good. And so that simplifies down to? 1, right? Like 5 divided by 5 is 1, right? Okay, so now we're at sine inverse of 1. Everybody's okay with that? So, because we're not told, we assume that the values we're looking for are between negative pi over 2 and positive pi over 2, because I'm, again, using my standard range for sine inverse. So once again, we remember that this is quadrants 1 and 4 for the range of theta, and it's quadrants 1 and 2 for where sine is positive. So I'm looking in quadrant 1 for where sine is equal to 1. So on the UC, I'm looking for the y coordinate equal to 1 in quadrant 1. What angle in radians do we find? Looking in quadrant 1 for the y coordinate equal to 1, what angle do we find? What? But we want it in radians, so pi over 2. Excellent. And that's our final answer. Everybody okay still? All righty. Next example. Yes, sir. Sure, but you're going to miss the tricky example here. Okay. Just letting you know. So this is the one where your math teacher is trying to trick you. So if I look at this, it says arctan of tangent of 2 pi over 3. So you hope that you can just do that where tan inverse cancels tangent. We can say this. Too bad, that's wrong. This is why it's a trick, but I'm showing it to you now. Unfortunately, it doesn't work that way. Why not is the question, because it feels like it should, right? Remember that the fundamental range for tangent is negative pi over 2 to positive pi over 2. 2/3 pi does not fall in that range. So what are we going to do instead? Nope. We can do it. We're just going to do it the exact same way we've done before. There's just no shortcut through it. So we start with the inside. So I locate on my unit circle 2 pi over 3. And I know we're going to tangent is y over x. So on my unit circle at 2 pi over 3, what is the y coordinate? Are you sure that's not the x coordinate?
Oh, I'm sorry, that's the x coordinate. It's square root of 2.
Root.
Square root of 2.
Yep. And then the x is, yeah, sorry. So we're there. So when I simplify that, I get negative square root 3, right? Now, what I'm left with is arctan of negative square root 3. So I'm going to go back to the unit circle and look for, well, let's think about what quadrant our answer needs to be in. Just like sine, I know tangent inverse has a range of negative pi over 2 to positive pi over 2, so it covers quadrants 1 and 4. And I see that tangent is negative here. Tangent is negative in quadrant 2 and 4. So I know my answer's in quadrant 4. Everybody's okay with that? So I'm going to be looking in quadrant 4. So I know that square root 3 came from a y coordinate with a root 3 over 2 and an x coordinate with a negative 1/2. But in the fourth quadrant, the y coordinate should be negative and the x coordinate should be positive. So I'm looking for that spot. So what angle in the fourth quadrant has an x coordinate of positive 1/2 and a y coordinate of negative root 3 over 2? Radians, please. 5 pi over 3. Everybody okay? Okay. So the problem is that this is not in the interval for tangent. Oh no, what do I do? I find an angle that's coterminal to it. Is 5 pi over 3 too big or too small? It's too big. So I should be subtracting 2 pi. So if I make my common denominator, I get negative pi over 3. That is inside my desired interval. So I should be all set. So the point of this tricky one was just to show you that you can't cancel them all willy-nilly. You still have to do the normal process, unfortunately. Okie dokes. Okay. One more. What's up? Sure. One more type of problem to show you. What if we have this same kind of composition of a trig and an inverse? But this time we don't have numbers, we have some algebraic expression in it. So for example, what if we have sine of arc cosine of 2x? The directions here are asking for an algebraic expression, so that means that our answer can have variables in it. That's okay. The good news is that this doesn't really start much differently. I'm going to start from the inside. Everybody's okay with me saying that? And I know that's equivalent to me just saying cosine theta is equal to 2x, right? Well, if I think about 2x as 2x over 1, I know cosine is adjacent over hypotenuse, right? So I'm going to go ahead and draw myself a right triangle with acute angle theta, where the adjacent side is 2x and the hypotenuse is 1. So far, so good. I'm going to call this third side y, and I'm going to use the Pythagorean theorem now to rewrite y in terms of x. So I can say 2x squared plus y squared is equal to 1 squared. Everybody feel good there? We're going to solve for y, so I'll subtract the 2x squared from both sides. I'll square root both sides. When I do that, I get plus or minus. But I've dropped the minus from the plus or minus immediately. Why can I do that? Why did I get to, when I took the square root of both sides, I should get a plus or minus tacked on in front of that square root, right? Why was I allowed to dump it? What is y representing again? A side length in a triangle? Can I have negative side length on a triangle? No, Mr. Kulik, you cannot. That's why I'm able to dump the plus or minus and just keep the plus. So far, so good. And the last thing I'm going to do then is just to simplify the 2x squared. So that's that. So I'll replace my y with square root 1 minus 4x squared. How do you guys feel there? So far, so good? Okay. So now, if I do sine of theta, I know from SOHCAHTOA, sine is opposite over hypotenuse. So using the right triangle that I've built, what is the opposite side? Well, it's square root 1 minus 4x squared. And what is the hypotenuse? 1. Sure. Or if I just simplify that, we have square root 1 minus 4x squared. So the process here, we're going to use the innermost function, the inverse piece, to draw a right triangle. And then with that right triangle, we can use the outer piece to evaluate our trig function. Should we do one more? This will be the last one, and then we'll be done. So again, I'm going to start with the inside. And I'm going to use that inside to draw a right triangle. I know sine is opposite over hypotenuse. So I can draw my right triangle, labeling the opposite and hypotenuse, and then my third side can just be y. I'll then use the Pythagorean theorem to try to get y by itself. So I'll subtract the 2 minus x squared from both sides. I'll square root both sides. I can dump the plus or minus because, again, the y is a side length. And then let's simplify 2 minus x squared. How do I do 2 minus x squared like that? How do I simplify 2 minus x squared? Let's ask us an easier question then. What's 3 squared? 3 squared? 9. How'd you get 9? 3 times 3, right? So 2 minus x squared must be 2 minus x times 2 minus x. Just like 3 squared is 3 times 3. When I have 2 minus x times 2 minus x like that, how do you do that? You have to FOIL. Yes. So I'll just FOIL that out quickly in my head. So we have that. Does that look okay? You're sure? You're now second guessing yourself because Mr. Kulik usually doesn't ask me if I'm sure when I shake my head as yes. In fact, that is not correct. I've made a mistake on purpose because it's probably a mistake 8 out of 10 of us would make. But I want to do that on purpose now so you can see it, so you're aware of it and you look for it. This is the mistake, not quite. That subtraction symbol needs to apply to the whole thing. And then we can combine the 1 and the minus 4. whew, Mr. Kulik, that was a tricky little guy there. I know, but I'm showing it to you now, so hopefully it's less tricky later. All right, so now we have cotangent theta. I remember cotangent is adjacent over opposite. The adjacent side is the square root 3 plus 4x minus x squared. And the opposite side is 2 minus x. That's as good as we can do. That's my answer. Sure. Is everybody okay with that? The pace today feel okay? I tried to make sure we're going slowly and carefully through things, not speeding along too fast. Feels like I got going too fast at points last chapter. Okay. So in addition to your worksheets 1 and 2 for Sunday, I'm going to add to it problems 11 through 14 and then 17 and 18. So that's 6 total problems here that we're going to add on. At this point, I am signing off and going to let you guys work on homeworks, whether that be catching up still on some Delta maths, working on worksheets 1 and 2, or starting on this new stuff, whatever you feel like is the highest priority item for you. That is fine, but everybody should have some math stuff to be working on right now. I would like everybody to try to get a little bit of progress made on whatever the math part is that they are choosing to start with right now. If you're stuck on something or want to check something or want me to look at what you've done and give you some feedback, you're welcome to come up and talk to me. I am open for business. I'm just going to be sitting at my desk here and doing my own work as you guys are working. Is that, you guys feel okay? Feel good? Maybe not good, you're in math class, right? But there are worse places to be. Here's a question for you. In all of human history, where is the worst possible place for you to be in?
Oh my God.
All of human history, the worst possible single day that you could pick to exist in. My pick would be, I'd not want to be a Roman soldier at the Battle of Cannae. So at the Battle of Cannae, the Carthaginian army does like a double envelopment. So basically they surround the entire Roman army, so there's no chance of escape. And they just spend like the better part of like 10 hours like slaughtering 50,000 Roman soldiers just by like swords and spears, just running people down and then like stabbing them again. At the battle site, they found that like there are Roman soldiers at the middle, so you've been waiting, watching like your other soldiers be slaughtered all day, that decided that like, I don't want to wait for this, and found them like had buried their heads in the sand and like suffocated themselves rather than wait just to get like murdered in the most horrific way possible. It'd be a bad day. It's a bad day. Although Pompeii would be no picnic either.
About that. I don't think I want to do that.
Yeah, getting buried by burning ash and suffocated by like heavy gases.
Yeah, I wouldn't want to do that either.
The catch for that one though is you would have had a chance to get away,
Yeah.
because you would have seen this coming for a while.
Yeah.
Yes. And lots of people did leave. So the battle is, if you run away before the battle starts, you're going to get killed anyway.
Yeah.
So like that's a rough one where there's like no survivors.
Was the Boston molasses flood?
Yeah,
A whole city covered in molasses.
be pretty gross.
Sticky, nasty.
Yeah.
Right here in Boston.
Oh, I guess we're recording then.